Hello, we are going to start a new set of questions. I'm going to make this set of questions available in Escape, so you should be able to download it. Unfortunately, there are a couple of mistake in especially in question one. Let's see. Let's have a look at the question one and see what the mistake is. Okay. All right. Now, if you look at this question, question one, which is hydrogen chlorine react to make 2HCl. In this question, what is missing is this. Uh, they haven't given us whether this reaction exothermic or endothermic. Now, in this case, when hydrogen reacts with chlorine, it's a spontaneous reaction that produces a lot of heat. So, which is exothermic. All right. Okay. Now let's look at the question part A. Part A. What is the question asking us? State the effect of increase in temperature. So when temperature is increased, what would the system do? System will partially. What would the system do? When you increase the temperature, what would the system do? System will partially oppose the change by trying to decrease the temperature, right? In order to decrease the temperature, system should have a look at the question. System should favor the not the exothermic reaction, reverse endothermic reaction, right? System should be favoring the reverse endothermic reactions. Reverse reaction is endothermic. So what happens when a reverse endothermic reaction is favored? You will be using hydrochloric acid to produce hydrogen and Cl2. In this case, the state the effect of increase in temperature. You have to say when temperature is increased, system will partially oppose the change by trying to decrease the temperature. Therefore, system will favor the net reverse reaction. When net reverse reaction is being favored, HCl concentration of HCl is going to decrease. HCl concentration will decrease, right? Will decrease. Simple question. Now, uh, again, if you look at part B of this question, I'm so sorry. I think this question should have been changed. Okay. Now, according to this, if you look at this, it says state the effect of increase in temperature. I think this question should have changed to not the increase in temperature. We are trying to state the effect of increase in temperature. It should be increasing, not the temperature volume, because I think the question was meant to be. If you look at the answer, you will see that. I mean, if you look at the answer of this question, it was meant to be uh, volume change, increasing the pressure by changing the volume. It should not be the temperature. Okay, that is what I think. Okay, let's go back to the question. Now here, what is the question is asking? Okay, asking you when you increase the volume. Okay, you know that the pressure will uh, decrease. Uh, pressure pressure will decrease. So what would the system do? System will partially oppose the change by trying to. Okay, let's put it this way. You increase the volume, then by increasing volume you are decreasing the pressure. That is U, right? Then what would the system do? System will partially oppose the change by trying to increase the pressure, right? Increase the pressure. In order to increase the pressure, what would the system do? System will favor the side with more particles. Yeah, side with more particles. But if you look at this equation, you know that both side has got the equal number of particles, right? Both side has got the equal number of particles. So there is no shift in the equilibrium. So there is no shift in the equilibrium here. Is that clear to you? So there is no shift in the equilibrium. Therefore, what do you have to say here? You increase the volume, pressure will decrease. Pressure is going to decrease, but there is no shift to the equilibrium. So there is no shift in equilibrium. So pressure will decrease, and it's not going to be partially. System will not partially not going to partially oppose the change. So pressure will be decreased. Okay, pressure will be decreased is the answer. So in this case, we have to say, what do you have to say? Pressure will decrease. There is no change in shift in equilibrium to partially oppose the change. Is that clear to you? All right. All right. Let's look at the next question. Now, next question is based on an equilibrium system, which is a aqueous equilibrium system. So as you can see this is, they are all aqueous, isn't it? You see that they are all aqueous. So this is not a gaseous equilibrium system. So when it comes to aqueous equilibrium system, it is important that you focus on concentration. Okay, or is that clear to you? If it is an aqueous system, you need to focus on the concentration. All right, don't say anything to do with pressure. You should not mention anything to do with pressure, because this is not a gaseous system, this is an aqueous system, right? So everything is about concentration. All right, let's go back to the question. Here, what do you have to say here? Fe3 plus SCN minus FeSCN, they have given you what? The colors of each species. So in this case, what are we doing here? Okay, adding FeCl3. FeCl3 means what? You are adding FeCl3. When you add FeCl3, you know that it's going to dissociate into Fe3 plus and Cl minus. In other words, you are increasing the concentration of Fe3 plus. Then what will happen when you increase the concentration of Fe3 plus? Yes, it's going to become yellow at the beginning because you are adding Fe3 plus. Then the system will partially oppose the change by trying to decrease the Fe3 plus. In order to decrease the Fe3 plus, system should favor the forward reaction, right? Because when the system favors the forward reaction, system will end up using Fe3 plus, right? Fe3 plus. So Fe3 plus concentration will decrease. However, since you are favoring the forward reaction, you are increasing the concentration of FeSCN3 plus, right? So what will happen when you increase the concentration of FeSCN3 plus? As you can see, it is going to become what? It's going to become darker red. So that's simple. Okay, adding KSCN minus. Okay, now it's like adding Fe3 plus, isn't it? So SCN minus is one of the reactants. So when you add SCN minus concentration will increase. System will partially oppose the change by trying to decrease the SCN minus concentration. Therefore, system will favor the net forward reaction. Then again, the darker red color will increase. Okay, is that clear to you? All right, the last part. Now let's have a look at the last part. Last part is adding water. What happens when you add water? What happens when you add water? You increase the volume of the ecosystem. What happens when you increase the volume of the ecosystem? Concentration of the every species, I repeat, concentration of the every species decreases. In other words, overall concentration of the system decreases. Then what will the system try to do? System will partially oppose the change by trying to increase the overall concentration of the system. Now this time, all the particles are affected. Concentration of all the particles. Okay, let me clean that up. Concentration of all the particles are affected. All right. So system should try to do something to increase the concentration. In order to increase the concentration, a system should favor the side with what? System should favor the side with more particle. So in other words, reverse reaction will be favored. When reverse reaction is going to be favored, right? What will happen? It is going to become more yellow, but it is going to become more yellow, but it is still going to be the intensity of the yellow color. It's still going to be lower than before you add water, right? Because when you add water, concentration of everything decreases, but system can partially oppose the change. Is that clear to you? System can partially oppose the change. So still it will increase, but it still it will increase, but it is still going to be lower than the lower than the initial intensity of the yellow color. What is initial intensity? That is just before water was added. All right. Okay, that part is done. Let's look at the part D. All right. In order to do part D, what do you need to do? You need to write an equilibrium mixture contain gases of chlorine F2 and CiF3. A sample of argon gas is added to the mixture. So this is the equilibrium mixture. State the effect of adding argon on the amount of CiF3. Now, if this is in equilibrium, if this is a equilibrium system, so it should be something like that. ClF3, ClF3. Make sure you balance this equation. So this is 2, this is 3, right? Now, in this case, what are we doing? We are adding argon. Now, look, I don't think, I'm so sorry to tell you, these questions are not written in a perfect, I was meant to say this, not, these questions are not written perfectly. Look, there are mistakes in these questions. So let's try to do our best, okay? Now, the question should have said, what is the effect of the equilibrium? The question is saying amount of CiF3. Amount is the number of moles, okay? Now, the thing is this, argon is a what type of gas? It's a, argon is a noble gas, which is unreactive gas, which is group 18. So when argon is added, argon is not going to react with any of these species in the equilibrium system. So therefore, what? The concentration of those species are not affected. So equilibrium is not affected. So system is not going to partially oppose any changes. So in other words, system is not going to system is not going to favor the net forward reaction or the reverse reaction because the concentrations are not affected. Is that right? Okay, pressure will increase. Is that what you're asking? Yeah, overall pressure will increase, but partial pressure is not going to be increased, right? I mean, they should have said you're adding argon they should have said this. What? They should have said this. They should have said the argon is added under constant volume. Yeah? They should have said that argon is added under constant volume. They are not saying that here. So the answer is there is no effect to the equilibrium system because argon is a unreactive gas. So the concentration of any of these species are not going to be affected. So there is no effect, right? Equilibrium is not going to be shifted to left or to the right. Is that clear? All right. The next one. Okay. E. The gas mixture is transferred to a new container that is half of the volume. Sorry about that. So half of the volume means what are you doing here? You are half of the volume. You are increasing the no, you are decreasing the volume. You have decreased the volume. By decreasing volume, what you have done? What have you done? You have increased the pressure of the system. When the volume is decreased, pressure has increased, right? Then what would the system do? System will partially oppose the change. Okay, write that down. Okay, write that down. You have increased the pressure of the system. Always go with concentration of the pressure, right? So in this case, let's go with the pressure. You have you have increased the pressure of the system. System will partially oppose the change by trying to decrease the pressure. That's what the system do. System will partially oppose the change by trying to decrease the pressure. In order to decrease the pressure, system will favor the side with more particles, right? More particles. System will favor the side with more particles. Therefore, right, what will happen? Therefore, concentration of ClF3 will increase. Concentration of ClF3 will increase. Now, The problem was the tricky part of this question. Now have a look at the tricky part of that question. You had to come up with a what? A balanced chemical equation. Otherwise, you would not be able to work out the side that is going to be favored, right? So make sure always when it comes to equilibrium questions, check whether to see the given equation is balanced. Man, it is almost like 1 o'clock. Or I'm sorry about the fact that I'm making mistakes. All right, but let's do the best we can. All right. Okay, I'm going to come up with another question soon. All right. I'll see you soon. Thank you so much. Bye bye.